Hi all, move ahead with our next topic. So before going for the next topic, there is why concurrency control is needed. So just we'll see how we return the transaction. So here transaction we can write it in two ways. There is one like this one. There is a using shorthands, or like this one. One more rotation of transaction just as a continuous. We can write T1. So then we can write the with on which item what kind of operation you are doing it. So that is here you are doing the read operation, some update in write operation, and again read item on the x item. Okay, so update then write item. So like this, t1 transaction, t2 transaction, both are different transactions. Okay, so here, or you can write like this. So shorthands normally will say, see here this is b1, so this is nothing but beginning of transaction 1. Okay, so then these all whatever we are writing as a 1 is nothing but representing the first transaction. Okay, so e1 is the nothing but end of the transaction. So here in between what you are doing is reading. Okay, so update part normally will not prefer in this one. Okay, so that is read, then whatever write is there, then again read and write. So in between maybe some update part or some functionalities you will do it, so that will not prefer in this one. Okay, so here second transaction b2. Okay, so we are reading the here this item. Okay, then just we are updating it. So here y, okay, so y item we are reading it, just we are writing it again, and it's the end of the transaction. So this is what the notation we had. So our main intention of this one is, so normally we will be having the less number of CPUs, okay, and more number of processes. So what we will do is we will always perform the interleaving. There is nothing but concurrency. We will try to perform it. So more than one transaction will try to run at the same time by using interleaving concept. So we require the concurrency. Okay, so whenever you are doing the concurrency, there should be some control also. Okay, so why control is something, but if you are doing some interleaving concepts, okay, so there may be chances of some problems. Okay, so what are those problems will happen if randomly you are interleaving the all the operations. Okay, those will see it. So that's why you require the concurrency control. You required it. So how you have to do the concurrency, that control you should require. Okay, so what all kind of problems will happen is, first one is lost update problem. Okay, so here if two transactions are trying to access the same data item, okay, so and operations are interleaved. Okay, so that time one is updated the data. Okay, and other is not referring that updated data, maybe some incorrect data it will refer it. Okay, so that is lost update problem. So will happen, suppose t1 transaction updated, t2 transaction is not looking for that. Okay, so for example this one. Okay, so here we have two transactions t1 and t2. So whatever we'll write here, these are nothing but same. These example whatever we took it, these are the operations. So t1 will perform these operations, t2 will perform these operations. So consider as here in account x, and this is account y. So n amount will be deducted from x amount account. Okay, and it will be credited in y account. Okay, and parallelly or some other transaction is there, so in x account m amount of money will be credited. Okay, so this is one first transaction, debited from here, credited here. Okay, from x to y, consider the transfer. Okay, that is n amount you are transferring it. So here, so in x you are just crediting it. So there are two transactions. Okay, we'll take, so these are the steps. Okay, so we have these steps. So these steps only will take it. So what are problems we may happen? Okay, so two transactions you want to run at the same time. Okay, so it's something with this whatever will represent this line, so nothing but time. Okay, so here time 0 you can consider it. So one by one operations will run it. So time t it will come. Okay, so like that we will proceed it. So here whenever you are starting it, so consider as a, when we want to interleave the two transactions operations, so consider as a first two operations we executed. That is read of x, then x minus n we did it. Okay, so we stopped with t1 transaction, then we started with t2. Okay, so that's why here gap is there. Okay, so we are time here, so whatever is there, these two operations were performing, that is T2 transaction is reading the x, and x equal to x plus m it's doing it. So So then the T1 transaction X is writing it, Y it will read. So again we'll stop T1, so we'll go for T2. So T2 transaction will write it. Okay, then T1 transaction, whatever remaining task, it will do it. Okay, this is what we are trying to do it now. Okay, so what will happen here is, if you saw here, X is modified. Okay, and before it writes to the our database, okay, this X is read by, that is from the database only it will read the, T2 will read it. Okay, this it will read it and it will manipulate it. So this one also we are writing, T1 also we are writing. On top of that, T1 with respect to X item we are writing it, and on top of that T2 also to write it. So there is a inconsistency data. So for example, consider say in X you have amount as a 100, okay, and N value as a 10, M value as a 20. Okay, so here suppose if I transferred from amount from X to Y account, that is X minus 10 will do it. So it will get to the 10 rupees to the Y account. Okay, so here it has to become as a 90 rupees. Okay, so in X it has to become as a 90 if I am doing separately this one. Okay, so T1 only separately I am doing it. Okay, so it will become as a 90 rupees. After that 20 rupees is credited, so it has to be a 110. Okay, so but here what is happening is, suppose if I interleaving like this. Okay, so here this is 10 is deducted. Okay, and 90 it is trying to write it. Okay, and T2 transaction is reading the data item X from the database. So when it's reading, so both will read, because it's not written somewhere anywhere in the database. So this will read as a 100 only. So initially it was 100, so 100 it will read it. So 100 plus 20 it will do, so it will come as a 120. So this will write as a 90. On top of that, this T2 transaction will write as a, this one as a 120. So in the end we'll get result as a 120. Instead of we have to get as a 110, so we'll get as a 120. Okay, that is a wrong result, we'll get it. So that is what is here happening is, item X has an incorrect value because it's updated by T1 is lost. So whatever T1 is did, so that operation were not at all considering only. So this is a lost update. Okay, so here T1 transaction, whatever update is did, so this update were not at all considering it. So that update is lost. So this is the first problem, is lost update problem. So if two transactions, okay, reading the data, and here this data is manipulated by one transaction, is not referred by the one more transaction, so that time this lost update problem will come. Okay, then we'll see for second one, temporary update. Okay, so that is dirty read. One more name we will say that dirty read. This will occur when one transaction updated database item and then the transaction fail for some reason. Okay, so it will update it. Okay, so by that time second transaction will read that update value and first transaction will fail it. Okay, so what is that, we'll see it one example here. So consider say T1 is reading X. Okay, so then X minus En we are doing it, we are writing it also. Okay, so here we'll write it. So this is written in our database. So now T2 will read it. Okay, so modified version of this X will read it. Then it will update it. Okay, so T2 will update it. Then this will write it also. Okay, so now still T1 is not completed. Okay, so still T1 task is there. Okay, that is read Y. Okay, update the Y, then write Y, like that operation is there in T1. Okay, so somewhere here failure will happen for a T1. Okay, so what it will do, instead of commit, that is nothing but successfully execution, instead of that one it will say as a abort. Okay, so here it will stop the working of this one. So whenever it will stop it, what will happen is entire transaction whatever we did it, those all operations we have to neglect it. Okay, so here what we did is modified and written in database, so that database value we are taking it. So suppose T1 is aborted here, so whatever operations we did, so those all are failures. Okay, so we will consider the all are failures, but T2 is reading the data which is updated by T1. Okay, here if you saw X item, so this is updated by T1, that is reading, then it's modifying it. So here also again some abnormal values will come. Okay, that's what we'll say is here normally temporary update value. Okay, so update problem or dirty read. So there is another thing, but this transaction is failed, that is modified, that value you are reading it here. So that's why this is a dirty read. So invalid data you are reading it. Okay, this is a wrong result. Okay, so this is second kind of problem. Okay, third one is Okay, that is incorrect summary problem. So if one transaction is calculating the aggregate summary of function on a number of records, while another transaction is updating some of these records, then aggregate function may calculate some values before they are updating it. Okay, so for example, again we'll see it here. So consider that T3 transaction is there, so it's calculating the aggregate of some values, some records. Okay, that is A2 considers a Y, some n records are there. So for all records, it's doing the sum. Okay, then it's calculating the aggregate. Okay, so in that T1, what it's doing is in that two items it's modifying. So whatever items are referred here, in that two items are modified by T1. Okay, so that is X and Y. Okay, so X and Y here, whatever we're doing it, those will be modified here. Okay, so that time we'll get the inconsistent result. Okay, so this is the we are saying it. So how we'll get it, that we'll see. Suppose T3 started early, so because here is a timeline, we are not doing any task, so T3 will start sum equal to 0, we took it, read A. If sum equal to initially it was 0, so A item we added in sum. So like that, one by one sum we are calculating it here. So n number of items, so in between somewhere. Okay, so here we don't have any task in T3, so it will read T1 task, that is X will be read. Okay, so X will be modified, that is we have to transfer amount from X to Y. Normally taken the example. Okay, so here X we read, so n amount is deducted, so and X is written in database. Okay, so before it modifies the Y. Okay, so because n amount is reduced here, it has to write it back into the Y now. So before we write it to the Y, so this calculation will get over. Okay, so T3 will finish the calculation. So what will happen is n number of amount will mismatch here. Okay, that is nothing but here we are saying is a read X. So this is written n after subtracting, this is read by T3 transaction is reading the X item. Okay, so then it will calculate the X sum for X also. Then Y also it will read it, it will calculate the sum, then it will calculate the aggregate also. So this task will get over. So after this, if Y is updated, okay, so here aggregate value will get the mismatch, because n you are not considering in X also, because it's debited here, and before credits you are calculating the aggregate, so n amount will be mismatched here. Okay, so this is what the problem will happen if we don't have the concurrency control. Okay, if you don't have the concurrency control, so that's why you should have concurrency control, and for that you have some different algorithms also. Those also will study it. So before that, again we'll study for why we require the recovery. Okay, that is nothing but if something has happened. Okay, so here problem has happened, you have to recover it. So this is the one of the examples we took it. So which all cases you have to do the recovery, that will study it. Okay, so here like if any problems are happening, you have to recover the whatever things you did it. Okay, so now we'll study why we require the recovery. Okay, so why, and there are some chances when your system or software will get failed, so that time you have to do the recovery. Okay, so what all conditions is, first is computer failure, or your entire system is crashing it. So that is nothing but hardware or entire whatever software OS or anything major problem is there. So that time normally we say as a this is a system failure. Okay, so that time your recovery you have to do it again. Okay, so that time, and second one, a transaction or system error. Okay, so while executing the transaction, maybe you got the some error, so that time you have to stop that transaction and you have to recover it back. Okay, so for example, in your transaction you are doing the divide by zero operation. Okay, so divide by zero operation is nothing but normally we will get as the infinity values. Okay, so those kind of things are not supported here. Okay, so in normal digital world, so what we'll do, a transaction will stop it. Okay, or integer overflow, so whatever 32 byte will be there, but your integer value is more than 32 byte value. Okay, so that time you have to stop the transaction. Okay, so those kind of things will happen, so you have to stop the transaction, and whatever previously task it did it, you have to recover it back. So okay, then third one, local error or exception condition detected by the transaction. Okay, so local error means some conditions maybe you are checking it while performing the transaction. For example, insufficient account in your balance. Okay, so in here normally if you want to withdraw the money, so you should have a sufficient balance also. So otherwise that transaction will get aborted okay, I cancelled. Okay, then whatever previously you did it, if you have performed some task there, so those all you have to keep it back. Okay, so if you did anything before that, so everything recovery you have to do it. So for that purpose it will happen. So withdrawal of money while doing it, if you have insufficient balance, so that is a local error. Okay, so for that exception will be handled, and whatever you did the a task, those have to be recovered. Okay, and so if, some errors will come, or you have to interleave the things, so concurrency you have to do it. So for that purpose you have some algorithms. Okay, so for particular algorithms kind of things. Okay, so again there may be a problem. So whatever problems we saw it like this, maybe some problems will come. So that time you have to abort one or two transactions only, and you have to restart it. Okay, that is a part of our algorithms. Okay, so here concurrency control enhancement. Okay, there is nothing but if concurrency control method we are using it, so different algorithms, so we are using it, so that time maybe you have to abort some transaction and restart later. Okay, so because those are violating the serializability. So what is serializability, we'll study it. Okay, so there is nothing but how exactly it has to happen, that is it's not happening, or it may be reaching as a deadlock state. Okay, so that's why you have to stop it. Okay, that transaction you have to abort, that's whatever things are did, you have to recover it, and you have to start it after some time. Okay, or disk failure may happen. Okay, so fifth one, so here disk block may be may lost their data because of the read or write malfunction. Okay, so it's nothing but we are saying is a read and write head will be there for the disk, so that maybe disk read and write head it's not working properly. So or in disk something problem has happened. Okay, so for that purpose again you have to do the recovery. And last one is physical problems or catastrophic. So here physical problems are nothing but maybe wherever you kept your database and their AC is not working properly, so it will overheat it. Okay, or fire problem is there. Okay, maybe some earthquake happened, or tapes or whatever you have to mount it instead of that place you mounted in some other different place. Okay, so physically whatever things may happen, for those all type of errors you have to do the recovery. Okay, so you for these all purpose you require the recovery. Okay, so now see next one. So again this what is transaction, little bit again we'll go ahead with, then we'll see what are the states will come in transactions. Okay, so here our transaction is nothing but we are saying is a it's an atomic work. Okay, so till now whatever we are saying is a task of operations it will do as a read and write operations on the database. Now we are saying that it's an atomic unit of work. Okay, that's why atomic is nothing but that's why we studied you have to do the recovery. Some problems may happen. So if we am considering this T1 transaction, so whatever things are there, these all together is we are saying as an atomic work. Okay, so these all operations together. Okay, so we are saying as a atomic work. Here T3 transaction, these all operations are there, so these all operations together we are saying as a atomic work. So if I have to run the transaction means I have to run all these instructions, or I should not run any of these. Okay, so there is a new thing will come it. Okay, so here, so this atomic work, either it has to complete entirely, or you should not do all the operations only. So whatever operations are there, those you should not perform it. Okay, then for recovery purpose the system needs to keep the track of the when transaction started, when it will get over. Okay, so whenever you start the transaction, that time you have to take care of whenever recovery you have to do it, what point of recovery you have to do, those all things you have to start it. Okay, so that's why here transaction when it is starting, when it's terminating, and when you're committing, those all things you have to write it somewhere. Okay, so how we'll write it, all those things we'll study it. Okay, so before that, so transaction what all things will be there. Okay, in transactions you have 5 states. Okay, so like process whatever you had the states like this, you have the 5 states. Okay, so first one is active state. Okay, partially committed state. Okay, committed state, failed state, then terminated state. Okay, so this is a transaction diagram. Okay, so here first begin of transaction will happen. So whenever it will start, so we'll consider as it's an active state only. So in this active state we'll perform all the things. That is nothing but read operation, write operation. If you want to manipulate something or some value you want to update it, those all things will happen here only. Okay, so whenever you will perform this operation, you will say as a, so transaction is over. So you have to mark it somewhere as a end of transaction. Okay, so transaction is over, so that time we'll say as a partially committed. It's not completely committed, just we're saying as partially committed. Okay, so why partially committed is, now this point of time whenever we'll mark it as a end of transaction, we'll see. So we are doing the concurrency. Okay, so we'll see is it because of concurrency whatever we did the transaction operations executed, is it giving some problem or not. Okay, with respect to the algorithms, if it is not giving any problem, then we'll commit it. So this is a completely will come do the commitment. Okay, so it's a, in database completely will write it. If some problem is occurred, okay, or concurrency is not there properly, okay, so that time we'll abort that one here. Okay, so here we will abort it. So there's nothing but it's a failed, we'll say it. Okay, or while executing this one only, or in whenever we're there in active state while executing something, maybe we'll get the abort. This is nothing but insufficient balance. Okay, so like that, if you have some problem, okay, so it's a local error. Okay, so whenever you have some problem, so that time automatically it will abort it, so it will come as a failed. Okay, so then, so it may failed or completely committed. In the end we are going for a terminated state. Okay, so here will say that this transaction is terminated. So from begin, so it may go in partially committed or committed. So partially committed is nothing but here we are saying as a, this is, we are waiting for to check the system everything is working properly or not. And there is nothing but serializability is there or not, we'll check it here. Okay, so what is serializability, we'll study it later. Okay, so it will check it here. After that it will commit it. If it's not there means it will abort. Okay, then both will reach to the terminated state.